Okay. Good evening, everyone.
Good evening, everyone.
Yeah. So I
Good
hope
evening, sir.
yeah.
Good evening,
So
sir.
today I am having some issues in letting people join. So I have to manually allow everyone. So yeah. So if anybody is rejoining or something like that, if they are having issues, so just let me know. Otherwise, I will just try to manually let everyone join. I have one notification. Which kind of info? Okay. Okay. So let us start our discussion. So welcome everyone again. This is our NPTEL lab session of week 11, and this is going to be our second last session of the course. So this is the course on non-conventional energy resources, which is taken by Professor Prathap Haridoss from IIT Madras, and I will be taking your introduction session for today. So my name is Lalit Bharti. I am a Prime Minister's Research Fellow in the Department of Physics at IIT Kharagpur. These are my email address and my LinkedIn profile URL. So you can connect me over there if you have any kind of issues and any kind of queries. So basically, this is our week 11, and we will try to cover different type of fuel cells and some part of our batteries. Then we'll see a few questions from our last week from the batteries. So we'll start from the assignment questions. So this is basically our first question on fuel cell. So what is basically a fuel cell? So we have already seen the mechanism of battery, which is a storage device which store your electrical energy in the form of chemical energy. Then when you require or chemical or electrochemical energy, then when you require the energy, you can again convert it in the electrical form of energy. But in case of fuel cell, if fuel cell is it is also an electrochemical device. So it is an electrochemical cell that converts the chemical energy of a fuel by oxidizing the fuel. It may be using some agents, and it converts it in electricity through a redox pair of reaction. So basically, we have a fuel. So if you see this kind of this is the typical schematic for a fuel cell. So we have a fuel. So usually it is a H2. So it is typically a hydrogen fuel cell. Then we have a cathode. We have an anode. These are maybe made up of metal oxides and similar to that. Then we have a again we have a electrolyte. So the purpose of the electrolyte is again similar. This is a ion exchange conductor, or you can say it is an ion conductor similar to our batteries, which allows the ions to conduct but not the electrons. So it will also allow the different ions, may be it be positive or be it be negative. So it will allow them to move from one electrode to another electrode, and electrons will be uh, travel through the external circuit. So this is your load. So okay. So you have hydrogen from here. One side you have some oxidant. So because alone H2 cannot produce any, or it cannot start any reaction. So you need some oxidant. So we have H2 as fuel. Then we have oxidant. We have these different cathode and anodes to perform the reaction. And as a byproduct, you will get H2O. So it is the byproduct or the product of the reaction, and H2 at both side, and you will get the flow of electron, which is basically your electricity. So the main issue or the main criteria for this kind of fuel cells is they operates at slightly higher temperatures, or it may go up to 1000 degrees Celsius, because if you need to perform this reaction, you need certain temperatures. So these are different type of fuel cells, and the temperature range they require. So solid oxide fuel cells type of fuel cell, they required around 700 to 1000 degrees Celsius to operate. And if you go for different for molten carbonate type, these are around 350 degrees Celsius. Phos- Phosphoric acid type, so they have around 200. Then polymer exchange type, these are at the room temperature, about 90 degrees Celsius. So the least temperature region, they have the polymer electrolyte type. So the question says an SOFC operates at operating 70 degrees Celsius. So the statement is false, because you can see the solid oxide type of fuel cells, they operate at very high temperatures. So this is one of the drawbacks of these kind of devices, that you need a very high temperatures to get the efficient operation of the fuels. So the statement one is false. So the false is the right answer. Then we have the second question. It says under constant current mode of operation, the degradation of a fuel cell may be expressed in mAh. So here, check for more. Yeah. So mAh is basically the capacity mA per H. mA per H means milliampere per hour. So you can see this kind of curve. This is the current density versus your voltage. So this is your ideal voltage, let's say 1.2. It is the highest voltage. Then you have some open circuit voltage where no load is attached to the system. So you can see that by increasing, if you see the current density, by increasing the current density, your voltage is decreasing. So you have different type of curves. So this is the ohmic loss. You have different type of losses. Ohmic is basically based on the concentration. Sorry, not ohmic is based on basically the resistive elements of the internal elements of the fuel cell. Then concentration loss. So if you have higher current densities, you will require higher concentration of electrolytes, or you can say that your flow of electrons will be very fast in, because current is basically representing your flow of electrons. So your flow of electrons very, if your flow of electrons is very high, the efficiency will be decreased after a certain limit. Then there is also activation loss. So you will get this kind of curve, the first, second, third. So first is decreasing, then 200 to around 800. This is your typical range. You can use the fuel cell. Then third one is sharply decreasing. So we should avoid this much of high currents. So the question says under constant current mode. So you need a constant current mode. The degradation of a fuel cell may be expressed as milliamp per hour. So this statement should be Okay. So the statement should be true that for a constant current, let's say for 1 hour, and if you are getting your capacity or you are getting your performance as a milliampere per hour, and if your current rates are lower, then you will get the uh, low number of flowing electrons, and your flowing current densities will be lower for the similar time duration. So your hour will be same. So you will get a degradation in your milliampere per hour parameter. So this question is on just the assembly of different fuel cells in you can say in a series connection. So it says two fuel cells each operating at 0.6 volt but at 0.5 ampere per centimeter square. So this is the current densities we are getting. It is around it is 0.5 ampere per centimeter square connected in a series. The area of each cell is 30 centimeter square. So you can just calculate the voltage of this stack. So I have not calculated it, but you can calculate. So if you have 30 centimeter square, so just multiply your 0.5 to 30. So the current output will be 6 ampere, sorry, 0.6 ampere for each cell. Let me calculate. 30 centimeter square, 0.5. Okay, so they are not asking for the current, they are asking for the voltage. Okay, for the stack voltage only. So this is your 0.6, this is your 0.6, but they are asking these are the hydrogen channel and this is your oxygen channel. So okay. So if you take 4, so it should not be the 1.2, it will be 2.4. Okay, so it is written wrong here. So because if you have 4 fuel cells in series, so you should add the voltages of all 4 of them. So if one is 0.6 volt, then 4 of them will be 2.4 volts for this stack. So it will be 2.4 instead of 1.2. So just correct it.
Sir, but in this question, two fuel cell is mentioned, but in figure 4 cell.
Okay. Oh yeah, sure. So that is why. Okay, I got it now. So it will be 1.2 volt because it is shown here. The figure is shown for four
Four
uh,
cell.
4 cells, but we have only 2 cells. So yeah, thank you for just noticing me. So it is 1.2 volt is the correct answer. Then we have this question. It says partial oxidation used for reforming fuels is an exothermic process. Partial oxidation used for reforming fuels is an exothermic process. So we need to understand what is the exothermic and endothermic reaction. So basically, when we have some reactants and we are getting some products after the reaction. So if you get some heat as with the products, so these are the exothermic process. Let's say this is the sign of heat. So you're getting some heat. So this is a exothermic process. And when the heat is absorbed during the reaction, then it is an endothermic process. So the products will be colder in compared to the reactants. So also we need to see what is the partial oxidation. So if you have fuel, you have air, and you are getting your carbon dioxide, hydrogen plus nitrogen. So this is a partial oxidation, means it's not completely changing. We have some carbon dioxide still present in the as the product. So in this process, it is also oxidation is like burning something. So it is also a process similar to oxidation of your fuel, any kind of fuel or carbon. So you will have some, the delta H is negative for that. So you have some heat produced during the reaction. So it will be a exothermic process. Then we have a next question based on the fuel cell and batteries.
Sir, one query, sir. Sorry for disturbance.
Yes.
If H is negative, so it is exothermic.
Hmm.
Actually,
Yeah, delta
here
H
you
is
have
the enthalpy.
enthalpy. Heat is not heat.
No, it is not the heat. Enthalpy is different from the heat.
So actually here you mentioned the exothermic. T increases, so R tends to P plus delta. It means
Sorry.
actually sir, you have written by red marker. For exothermic T increases,
Hmm.
so R implies that P plus delta. Yes.
Yeah, so if T increases, this is exothermic.
Temperature.
Yeah, temperature is increasing. R is your reactant. Then your product, you are getting the product with after the reaction, and you have theta means you have some extra heat. Plus theta means extra heat, and minus theta means the heat is absorbed. So let's say you are at room temperature at 27 degrees Celsius. So you are getting some product and your temperature increase. So let's say you're getting 100 degrees of the temperature. And in endothermic, if you have at room temperature, you will see your temperatures are decreased. So in that case, it is absorbing the heat. So minus delta is written there. So a typical example is when you mix, let's say, sugar in the water. So it is a endothermic process. So you feel that your water is slightly cooler than the previous without sugar. So it is an endothermic process. An exothermic process is like burning a fuel, mixing a washing powder in water. So you just mix the washing powder in the in the water. Then you will find that your water is slightly warmer than the previous water. So that is exothermic process, and typical
Yes.
oxidation or burning of a fuel is also exothermic process.
Yes.
And delta H is the enthalpy. So basically it is showing that if your enthalpy is negative, so the reaction is uh, proceeding from the reactants to the product. And enthalpy is your measure of your, it is also a thermodynamic parameter. And basically this is the measurement of energy. So in exothermic, this is negative, and endothermic, these are positive.
So we can say also, sir, by exothermic process means heat generated.
Hmm. Yeah.
Heat
So
is generated in
heat is
exothermic,
generated in exothermic process. Yes. So these all
and
parameters
delta
like
H is negative.
this Gibbs energy, this enthalpy, entropy, all these things are related to each other. So all thermodynamic parameters are, if you change one of them, all will change because these are all are interrelated.
Okay, sir. Thank you.
Then we have the next question. It says most batteries and fuel cells use uh, blank and blank reactants respectively. So we have liquid solid, gas solid, solid gas, gas liquid. So we already know that if you have, this is your fuel cell. Oh, sorry, this is a battery and this is a fuel cell. In batteries, we have cathodes and anode. So these are our reactants. In fuel cells, your reactants are the fuel, which is H2 and O2, and battery, these electrodes are providing the sites to this just to complete the reaction. in presence of your electrolyte, which is basically ion conductor. So we can say that yes, fuels are in gaseous form here in fuel cells, and reactants or the electrodes are solid in batteries. So your option third will be correct, that most batteries and fuel cells use solid and gas reactants respectively.
Sir, reactant means anode and cathode, fuel.
Reactants means what is the uh, if you take H2 here and you are getting H2O after the reaction. So your H2 plus O2 is giving H2O. So your H2 and O2 is your reactant. Then your H2O is your product. So here what is happening? So you use cathode and anode. So basically your cathode is participating in the reaction and cathode is transforming. Let's say if you are making using lithium cobalt oxide. So from LCO, you get some compound of L1 minus X CO. So that is your basically reaction. The cathode and anode are participating in the reaction. So basically, these are the reactants. These are not consuming in the nature in the reaction. So batteries are slightly different because here H2 will be completely changed in H2O, but in batteries you will get after a cycle your cathode will be similar to the previous. So it is not like consuming or just ending up like H2O, H2. It is not like hydrogen, but you can say these are your reactants. Okay. So basically your reactants are solid here, and in fuel cell you use gaseous form of reactants like H2 and O2. Then we have the next question. It says ionic conductivity of most of the electrolyte blank on increasing the temperature. So basically we have four options: decreased, increased, remain constant, various randomly. So we know that ionic conductivities of most of the electrolyte increases with the temperature. As you go down in temperature, your ionic conductivity will be lesser. And if you go up in temperatures, your ionic conductivity will increase. So basically, ionic conductivity is the movement of ions in electrolyte. So let's say if you're taking water as electrolyte, so movement of, as we know that heat is basically some energy. So if you provide heat to electrolyte which is having ions, so it will improve the mobility of the electrolytes. Improve the mobility of ions in the electrolyte. So by increasing the heat or increasing temperature, your mobility of or the conductivity of your ions will increase. So this is also some research data from where you can understand if you have some temperature here at x-axis and at y-axis your conductivities. So your conductivities are increasing linearly with the increase in temperature. Similarly here. So your question is for this question, the option 2 is correct. The ionic conductivity of most electrolyte increases on increasing the temperature. Then we have among all the fuel cells generates water at the. So we need to see that where the waters will be generated. So we have H2 at one side. So we have a cathode, we have an anode. So all options are cathode and anode are in the option. So we usually get the reactions here at cathode and your water is emitted at the cathode. So if your hydrogen is at anode, oxygen is at cathode, So you will get H2O at cathode in case of PMFC and PAFC, but not in the solid oxide fuel cell. So this is your PEM or proton exchange membrane, and this is also the similar proton exchange. So if in case of proton exchange, your proton will go from one side, from anode to cathode. So your direction of proton will be from the anode, from anode to cathode, because at anode you have the H2 only. So this is your source of proton. So H2 will be converted into H plus, and then this H plus will move to the cathode, and it will react with the OH minus ions, and you will get H2O. But what will happen in other cases? Your OH either your OH minus, your O2 minus, or CO3 minus. This will travel from cathode to anode to form H2O. So in these cases, you will get H2O and the byproducts like CO2 at the anode side. But in PEM, proton exchange, wherever you get the proton exchange means you will get your H2O as byproduct in the at the cathode side. So we have the options second and third option. We have these options are correct for our question 3. So be careful which ions is moving in the electrolyte, either H plus or H minus, and it depends on the which kind of technology you are using. Either these are oxide based, these are carbonate based. So MCFC means these are some carbonate based. AFC means alkaline fuel cells. So alkaline means you will have OH minus ions in the electrolyte. So OH, if you have the OH minus ions, so your OH minus ions will travel from one side to another side. For solid oxide, you have the oxygen O2 minus. For PEM or any acidic or any proton exchange, you will get H plus as your moving ion. So option 2 and 3 are correct. Then we have the fourth question. Yes. Yes, say. Hello. Can you hear me?
Third question.
Sorry, I can't hear you clearly. Or just
in
if
other
you're
all.
yeah. Your voice is not clear, so if you can also write in the chat box. I will just read it from there.
Now,
I still can't hear you properly. I suggest you to just write in the chat box. I will just pick your questions from there. Okay, so meanwhile, let me take the next question, and we are waiting to get the question of Dharmendra. So PEMC and SOFC differ significantly on issues such as presence of electrolyte, operation temperature, applications, location of the water generation. So PMC is basically the proton exchange membrane fuel cells, and SOFC is solid oxide fuel cells. So we know that proton exchange having H plus ions moving, and solid oxides are having O2 minus ions. So presence of electrolyte is not differ significantly, because in both cases we have some electrolyte. So electrolyte is different, but in both of the cases, presence of electrolyte is there. So operation temperatures. So that is clearly we know that PMC works at the room temperatures here, and your PFC, and this PFC at 200. So basically the PMC at the room temperature, and your SOFC solid oxide, these run at your high temperatures around 700 to 1000 degrees Celsius. So significantly your operation temperature differs, and depending on the temperatures range, your applications also different, because you cannot use the SOFC at your normal room temperature applications. So you need some high temperatures source at the fuel cell for using this type of fuel cell. Then location of water generation. So we have already seen that if you have acidic type of electrolyte, then you will get your H2O or water generation at cathode. Otherwise, you will get your water generation at anode. So in SOFC, it is at anode. So these differ in the location of water generation also. So option 2, 3, 4 are correct, and first is not correct for this kind of question. Then we have the next question. It says fuel cells processing involves two processes, reforming and cleaning. The following is true regarding these steps. So we need to see what is reforming and what is cleaning. So reforming is extracting H2 gas from the fuel. Cleaning is done to further increase the H2 gas purity. Then cleaning process converts CO into CO2, and during reforming process, the primary product is H2. So this is your flow chart. Basically, you have some fuel. So let's say you have ethanol, yes, ethanol is fuel here, and H2O. Then you have a steam reformer. So what is this reformer doing? It is basically giving you the H2. So it is breaking down the fuel. So you have steam reformer. So it is at very high temperatures in form of steam. So it will break down the fuel. You will get CO, CO2, CH4, and H2. And then we need the H2 as your source. Then we have water gas shift reactors. Then so all the methane will go down. Then we will have CO, CO2, and H2. Then preferential oxidation we will get. And during this preferential oxidation means we need to convert only one of the reactant to as a product. So only we need to convert our CO to CO2. So it is done in the preferential oxidation only. So only CO will convert to CO2. Then we have CO2 and H2. Then CO2 will be removed with some mechanism, and we get H2 only. Now we can use this H2 as our fuel cell. So this is the whole process from a typical fuel to fuel cell, and how the H2 is transported from the fuel to fuel cell. So now we know what is reforming. This first step is reforming, then the cleaning, and the CO2 CO2 reaction is called the preferential oxidation. So option 4 is incorrect. Oh, sorry. Option 3 is incorrect. And 4 is incorrect. It is saying that during reforming process, the primary product is H2O. So we don't have H2O as the product here. H2O will be getting at the last, either at cathode or anode. So reforming is the extraction of H2O. So yeah, that is correct. You are getting reforming H2S after reforming. Cleaning is the further done to increase the H2O purity. So this is basically the oxidation and the water shift reactor. These are cleaning. So you are getting for CO2 removal. These are the process of cleaning. So you're getting improved and high purity H2, and it also converts the CO into CO2. So this preferential oxidation comes in the cleaning process. So you get CO2 from the carbon monoxide, or carbon dioxide from the carbon monoxide. So option 1, 2, 3 are correct, and option 4 is incorrect. Then we have the next question on IC engine means the internal combustion engine and fuel cell. So the question is IC engine and fuel cell operation are based on blank and blank reactions respectively. So we need to see what is the IC and what is the FC means fuel cell. So IC is the internal combustion engine. Means you have some chemical reaction, you have some fuel, you will burn the fuel and you will get the product. So let's say carbon based fuel, then you have in presence of oxygen, you will get CO2. So this process is called internal combustion, and this is the chemical process, and this is typically done in your let's say car engine or by motorbike engines. So you have some fuel, let's say methane, ethane, whatever you take as your fuel, and oxidation you will get CO2 as the product. But in electrochemical, what happens? We have already seen what is electrochemical. There's some chemical reactions and the flow of electrons. So batteries and fuel cells comes in the electrochemical process. So the question is clear. These IC engines are the chemical based reaction based devices where fuel cells operations are electrochemical reactions. So option 2 will be correct for this question. Then we have the seventh question. So it says PMC can produce more current when the blank is increased. So PMC is basically proton exchange membrane type of fuel cell. So this is the schematic of PM fuel cell. So options are three-phase interface region, electrode electrolyte gas region, electrode gas region alone, electron gas region, electrode electrolyte region alone. So we have anodes cathode here. So these are electrodes. Then we have electrolyte, and these are the gas. So this is the gas region, this is the electrode region. So third option says electrode gas region, and fourth option says electrode electrolyte region. But we need to improve both of them simultaneously, and we need to optimize them properly to finish the reaction. Because if you just increase your let's say anode and electrolyte region, and you are not increasing your gas region, then the reaction will be limited by the gas region or the gas electrode interface. And similarly, if you just increase your gas region, let's say gas and electrode region, not increasing your electrolyte region, then it will be bottlenecked by the electrolyte region. So we need to improve three-phase interface region or electrode electrolyte gas region. So three-phase means all regions are included. Electrode, this is the solid, electrolyte, this is the liquid, and gas. So all three phases, this region need to be improved or increased to produce more current. And option third and fourth are incorrect. That only two regions are not sufficient enough. Then we have the eighth question. It says the voltage of a battery depends on blank of the reaction, while current from the battery depends on blank of the reaction. So we have four options: chemistry, rate, kinetics, thermodynamics, kinetics, rate, and chemistry. So we have already discussed that voltage is dependent on the type of battery and which type of material is there, which type of chemistry is used, and what is the thermodynamics. Means if you have lithium based battery, lithium ion batteries, the voltage will be different. If you have sodium ion batteries, and if you have, let's say, aluminum ion batteries, so your voltage will differ on the type of based on the type of your electrode. So you have these three parameters is majorly uh, giving you the voltage, but your current is based on your which rate you are using and what is the kinetics. Kinetics is basically the rate of the reaction. So what is the kinetics and what is the rate? It depends on the it will give you the current rate. So it is kinetic means basically your flow of your electrons. So option 1 and option 3 are correct. That chemistry and thermodynamics are giving you the voltage, and rate and the kinetics are giving you the currents of the battery. So we have already discussed in the last week also. So that is similar. Then we have the next question. It says you need to match the followings. So first we have the polarization losses and the region. So we have already seen that we have three type of losses. So this is your activation, first activation, then you have the ohmic loss, then the mass transfer loss. So this is your activation loss. We have already seen that your activation loss come at your lower current region. Then you have ohmic loss. Ohmic loss is basically depending on your internal resistance, or you can say the ionic conductivities, limited by the ionic conductivities. Then you have mass transfer and concentration losses when your currents are very high. So your current will be limited by the flow of electrons or the concentration of electrons. So this is the concentration region because your mass transfer and concentration is dominant here. So we need to just match now the reasons. So the activation is the reaction site has become bad. So this is due to the reaction sites activation losses. Then ohmic is basically electrolyte and membrane conductivity has decreased. So if your conductivities or your ionic conductivities are changing, so you will get or decreasing. So you will get your ohmic losses. Then if you have the pathways for reactants and reaction site is blocked. So if your pathways are blocked, your mass transfer will be affected. So if your mass transfer is affected and your concentration losses will increase in that case, so that is your mass transfer losses. So simply your A's will go to third, B will go to first, and C will go to second. So accepted answer is the fourth one. So this is your question 9. Then we have the question 10. So it is again on the calculation of current output from the from the fuel cell. So let's say if question is if cells with given with the specification of 0.2 ampere per centimeter square and 0.5 volt are sampled in series, then how many cells you need to and how much area each will be required to produce 1 kilowatt power. So simply you can just make these two combinations to make 1 kilowatt. 1 kilowatt means the 1,000 watt of power. Just multiply the current with the voltage. So let's say if you have 100 cells, then 100 times 0.2. So it will give you the current because we have the current density of 0.2 ampere per centimeter square. So you will get 20 here. And if you put 100 in series, then you will get voltage of 50 directly multiplying with the voltage, then you will get the output as 1,000. In other way, you can just take 200 in series and 15 parallel. So you will get again 10 to 100. So you will get again 1,000. So either make 20 in parallel 15 series or make 20 in series and 100 in parallel. Sorry, 10 in series and 100 in, sorry, 10 in parallel and 100 in series. So just check the what options we have. So 100 cells and 200 cells. So both can be correct. Okay, so this is done. Then we have the few questions from the previous week. So again, it is around an hour. So let us take a break of 10 minutes. Then we will just finish up these previous year questions, previous week questions. So it is 7:58. So we'll meet around 8 p.m. Okay, so let us finish our remaining questions from the previous week quiz. The question one is combustion of wood in absence of air primarily produces what? So we have charcoal, CO2, a solid which contains almost
Sir,
twice of
once
energy.
please repeat the question number 10, sir, if I am audible.
Question number 10,
Yes, 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 sir.
this one.
Yes.
So basically you need to make the combination just to get the 1000 watts of power. So 1 kilowatt or 1000 watts. So you can make it in two ways. You take 100 cells, just 100, just align 100 in parallel and 100 in series. So parallel will increase your current. Parallel will just multiply the current values with the 100. So you will get 20 amperes. And if you multiply the voltage in series, so it will be 50 volts. So 50 times 50 volt into 20 ampere, you will get 1000 watt. And another combination can be you have 200 cells in which 50 are in the you can say the parallel, and the 200, these all are in the series. All 200 will be in series. So you have 100 time and 100 volt and 10 ampere. So but here your area is like 50 centimeter square. So you can get two combination now. 100 cells with each with 100 centimeter square area, 200 cells with each with 50 centimeter square area. So in both of the cases, you will get 1 kilowatt or 1000 watt of power.
Sir, how to decide the area, sir?
So it is given in the options. So that is why I'm just saying you just check all the question options given and try to make the combination. So only two are correct here. So you will get for 50 meter 50 because only the density is given, the current density is given, no area is specified. So we have to check the combinations given in the options we have. So by this, only these two options are correct. Otherwise, for 100 cells with 50 centimeter square area, it is hard to get the combination right. And similar for the other option. So these two options, you can make the combinations of 1000 watt. So just put few of the fuel cells in series and few in parallel to make the combination. Then we have the option question one. So basically, it is based on the combustion of wood. So what you get after the burning, or you can say the combustion of wood. So option is charcoal, CO2, a solid which contains almost twice of the energy content per unit mass than the coal. And fourth is a solid material which is less volatile content. So basically, burning of wood is you have different elements. So it can be hydrogen, nitrogen because wood is organic, then some volatile elements. So in presence of oxygen, you get CO2. But if you don't have the oxygen or in absence of air, if you heat, so all will react and they will evaporate. Only since there's no oxygen, you will not get CO2 and you will get a highly pure form of carbon, which is which is a charcoal. So this highly pure form of carbon, it has the density or the energy content double or the higher than the coal. So option one is correct because it is charcoal. So in the energy is content per unit mass is almost twice than the coal. So option three is correct. Then four is also correct. Then you will have less volatile content. Option two is not correct because you will not get CO2 in absence of oxygen or in presence of air. Then we have the next question. So it says the power consumption at a typical home is same throughout the day, varies throughout the day, is typically high in the morning, typically high in the evening. So it is a typical energy flow chart with the time. So you will get this kind of curve. So in morning time, your energy consumption will high. In afternoon, you get some low. In evening, it's again high. In night, it is again low. So typically, most of the household works, all the chores are done in the morning time. So you will need higher energies. So you are using the, let's say, the heaters, the water heater, the for making food, you need some, let's say, gas or any kind of induction or heater you are using. If you are using, then you need high energy in the morning. Then afternoon, there is a depression in the energy consumption. Then evening, again, you need lights to light up the or remove the darkness. So you need some energy in the lights. Then you need energy to make or cook food and other energies. So your energy consumption will be high in the evening. Then in night, again, your energy consumption will be depleted. So it is option 3, 2, 3, 4 are correct. It is varies throughout the day and typically high in morning and evening. So option 1 is incorrect, which says it is same throughout the day. Then the next question is we need to match the following. So we have already done this kind of question. So we know which are the anode, which are the cathode, where the oxidation happening, where the reduction happening, and separator is allowing the movement of ions. Then we have external circuit, which is allowing the electrons to flow. So just match quickly. Electron flow is happening in the external circuit. Electrolyte is poor electronic conductor and good ionic conductor. Then ions are in the electrolyte. Anode is basically where the oxidation reaction occurs, and cathode is basically where the reduction process happens during the discharge. So just match the options and your option 2 will be correct. Yeah. So option 2 will be correct in this question. Then we have the next question. It says how to get a standard potential of a standard electrode cell. So we have seen the electrochemical series. So in the electrochemical series, if you remember, you took all the potentials with reference to H2. So basically your H2 is your standard hydrogen cell, and you take all the metals and all other elements with reference to that standard hydrogen electrode. So here it is, the standard hydrogen electrode is shown here. So options are, it is obtained by measuring the potential difference on the standard electrode with respect to standard hydrogen electrode. Okay, that is correct. It is obtained by the measuring the potential difference with respect to any other electrode. So that is not correct. Not any other. We just need the standard hydrogen electrode. And third is, it is obtained by subtracting the standard reduction potential of two electrode. So that can be correct. And it is obtained by subtracting the standard reduction potential of cathode and anode. So okay, so we need cathode and anode. So either subtract or take the difference of these two, and this will be your mechanism of simple mechanism of standard hydrogen electrode, and any another potential is taken with respect to this. So this is a schematic for your standard hydrogen electrode. So basically you have the 1 molar HCl solution, and you have some platinum electrode here, and another electrode is your typically your gas. So hydrogen is filled here. So hydrogen is one of the electrode, which is a cathode here, and this is your anode, platinum wire. Then you put it with connected with the high resistance voltmeter. In this typical setup is the called the standard hydrogen electrode. So option 2 is not correct, else all three options are correct. Then we have the next question. It says open circuit voltage of a half cell fabricated with lithium metal as anode will always be more than 3.4 volt regardless of the counter electrode used. So we have already seen that your any potential of any type of batteries or any or half cell, it depends on the what is the counter electrode you are using. So if you are using standard hydrogen electrode, it will be the different. If you are using some another electrode, then it will be different. So here it is shown for a typical lithium metal. If you are getting, if you're taking a full cell, so your carbon is your anode, so you will get around 3.7 voltage. But in in case of some another electrode, let's say standard hydrogen electrode, your potential will be different. So you can get 0.3 volt. So in this case, the statement will be false, that it is not regardless of the counter electrode. Counter electrode is important in the in determining what OCV is, what you are getting. Then you have the sixth question. It says battery and fuel cells are, again, we know that both are the electrochemical device, but these are not, both are not conversion device, because fuel cell, they are converting the fuel to electricity, but batteries are basically storing the electricity but not converting the electrodes in the electricity. So they are just, they are having some Rock-chair reactions, but rocking chair reactions, but not a conversion of electrode to electricity. So these are basically storage. Batteries are the storage type of system, but the fuel cells are the conversion type of system, and both are used in EVs. So you can check the question options which are correct. Both are electrochemical device, that is correct. Both are any conversion device, that these are not correct. Both are energy storage device. This is also not correct. Both can be used in electric device. So option 2 and 4 are correct. And this is the reason why we have discussed. Then see the question 7. It says the kinetics of a cell or a battery is affected by what? So we have, I guess we have seen this kind of question. So we have activation barrier, driving force, presence of catalyst, and internal resistance. So we know that kinetics is dependent. We have already seen the type of reaction, which type of reaction is happening. So kinetics, if you have some activation barrier, these reactants, the energy need to be surpass this energy level or the barrier energy barrier to make a product. So if this is lower, activation barrier is lower, it will easily make convert the reactants to. And one more thing is catalyst. So catalyst is basically the elements which are not directly participating in the reaction, but they are just improving the rate of the reaction. So these are basically decreasing the energy barrier. So by using the catalyst, it will be lesser and your reaction, the kinetics will be higher. So option 1 and option 3 is correct. And internal resistance and driving force will not improve the kinetics of that. It will just increase the voltages, affect the voltages, but not the kinetics of the cell. Then we have the question 8. It says we test the cell performance at different C rates because battery current demands might be different at different times. So yes, for the same application, different levels of energy may be required under different operating conditions. So yes, different energy level may be required. This gives us the better understanding of the battery capabilities. That is also correct, because at different applications, we need the different type of C rate, different C rate. It helps the comparing different batteries. That is also correct. So we already discussed C rates are basically the discharging rate of a battery. So 1 C means your battery should be discharged in 1 hour. So this is your typical battery charge discharge characteristic. So if you are increasing your current rates, so your capacity will decrease. So we have already seen. So this is for 3C, the green one, and the black one is 0.2 C. So for 0.2 C, your capacities are higher, and and 3C, your capacities are lower. So we have already discussed, if your kinetics are very fast, your capacities will be lower. And if you give sufficient time to a battery for So reactions to happen, you will get higher capacity. So all options are correct here. Then we have the question 9. It says for a full discharge of an initially fully charged 1Ah cell of lithium based cell, as well as the fully charged 1Ah of sodium based cell or Na plus electron based cell, ideal same under the electron will flow through the external circuit. Ideally, same number of electrons will flow through this. So we can see the reactions clearly that for a single reaction, you are getting lithium plus in 1 electron, and for sodium also, you're getting sodium plus in 1 electron. So basically, you are getting 1 electron. So that is true that the number of electron will be same throughout the external circuit. Just your voltages will be different depending on the electrochemical series and depending on the counter electrode. So in your lithium, your voltages or your OCVs will be slightly higher than the sodium. So this is your question 9. Then question 10 says statement is the material tested with programmable.
Sir, can we go
Yes.
to the last question?
Yes.
Okay. Suppose in this case, if we have 2 electrons in the discharge side, okay,
Yes.
then what would be the answer?
Yes. So then the answer will be false because okay, the
See
same
the
number
answer.
of electrons will. Yes. Let's say you have aluminum ion batteries. So what happens? Alumina have the valency of +3. So
Yes,
Al will convert in Al3 plus. Then
3
in a
electrons.
single reaction, you will get 3 electrode.
Okay.
Okay, so the same number of electron will flow through the external circuit. This statement will be incorrect because
Sir,
for a
sir, the
single
question,
reaction, your larger
sir, the
number of
question
electrons will flow.
that
Yes.
I got it, but the question is for the flow of 1 ampere hour. Okay, 1 ampere hour. So 1 ampere hour is just flow of 1 ampere current for 1 hour. Okay, and 1 ampere is fixed. The value of 1 ampere is 1 coulomb per second, and 1 coulomb is also fixed. The amount of charge in per electron, you can find the number of electrons. So irrespective of the flow of electron by the reaction, the total quantity of 1 ampere hour should be same. To get
Okay, let me just read the question.
to get a
Yes, yes.
discharge of 1 ampere hour, to get a discharge of 1 ampere hour, the number of electrons should be same, irrespective of the reaction.
Okay, so you are saying that this 1H, so you are also correct because your 1H means the capacity is 1 ampere
Yes,
for 1 hour.
yes,
So yeah, so that is irrespective of the technology. But
yes.
if they ask that what will be the number of electrons for a single reaction, then
Then
for aluminum it will be different.
yes,
But in
true,
this
true.
case, it will be, yeah, it will be true.
Okay.
So if any another technology is also there, if you fully charge, if you're taking for the same time and same capacities, so if you're independent of capacities, then you can say it is not true. But if the capacities are restricted, then it will be true in that case. So thank you for suggesting the different approach of the question.
Thank you, sir.
And the 10th question is a material tested with a programmable electronic load testing station working perfectly on 0.25 C rates up to 200 cycles. Material tested with programmable electronic load testing station working perfectly for 0.5 the C rate is given and for 200 cycles. So if it is a primary battery, so that is clearly wrong because primary battery means, so there are two types of batteries, primary and secondary. So primaries are which cannot be recharged and secondaries are which can be recharged for multiple cycles. So if they are saying that 200 cycles means it's clearly not a primary battery. So it is a secondary battery. Then the third option is single charge of the battery when discharged at this rate will last for 4 hours ideally. So 0.25 C rate means 1 C rate is equal to 1 hour. So you just divide. So 0.25 will be 4 times 1 hour means 4 hour of discharge. So ideally you should get 4 hours of discharge with this rate. So option 3 is also correct. So option 4 is it has the capacity to give steady current of 0.25 ampere for 4 hours regardless of its actual capacity. So that is not correct because it should be dependent on the which capacity you are giving. So if you have C rates of 0.25, you will get current at with 4 hour, but it is not regardless of its actual capacity. So its actual capacity will also play its role. So option 3 and option 2 are correct, and 1 and 4 are incorrect for this typical case. So questions for today, all assignments questions are done. So we have the 30 minutes more to go. So it is our discussion time. So if you have any kind of questions, queries, we can discuss till 9 p.m. I also request again to just mark your attendance. Just write your names if you have not written in chat box.
सर ये अटेंडेंस जो है ये हमारे जैसे कॉलेज में है तो फिर वो क्रेडिट्स में काउंट होते हैं?
नहीं, it is not for you, but we have to report that how many people are joining. If the trend is like the attendance is decreasing, attendance increasing, so we have to just note it down. So it is not for your side and not for the institute purpose. It is for us and for the NPTEL people.
ओके सर. सर जैसे इसके एमसीक्यूज है तो उसकी प्रैक्टिस कहाँ से कर सकते हैं? मतलब जो असाइनमेंट क्वेश्चंस है वो तो है ही, पर उसके अलावा कोई और साइट हो या फिर कुछ मटेरियल टाइप हो?
So the material is as such not available, but you can go through the previous questions, previous year questions, then जो assignments दिए हैं, because they will be making your question paper. So ultimately, whatever practice questions they have given, if you practice them, that is enough. And just the whatever notes they are providing. Any note कोई as a external source नहीं है. So they are making the questions. So they जिन्होंने assignment बनाए हैं, उन्होंने ही question बनाएंगे. So it's better to revise all the assignments, all the notes they have given, and whatever these kind of class assignments or the homework assignments, whatever they have given, just finish them. So it will be more than enough.
Sir,
Okay.
the same pattern will follow where the answers have multiple options, or the single option will be there in the final exam.
So similar kind of trend will be followed. So whatever you are seeing in the assignments, so similar type questions will be there. And they could also introduce some kind of numerical questions. So simple numerical questions you have already seen. So this kind of question may be also there, but no, I don't think there will be any write up like of question like you need to explain anything. So it should be the MCQ, MSQ, and the numerical. But if they gave any kind of instruction in any kind of notice, then just follow the notice, because we don't have the official notice of that which kind of questions will be there. But I'm just giving you the suggestion that the question will be similar to that.
Okay.
सर एक और बात पूछनी थी, लाइक अगर हमें किसी को कांटेक्ट करना हो, जैसे आप तो सर पढ़ा रहे हो, पर अगर एडमिट कार्ड से रिलेटेड या फिर लोकेशन से रिलेटेड जहाँ पे एग्जाम सेंटर होगा उससे रिलेटेड अगर कोई क्वेरी हो तो फिर सर किसको कांटेक्ट करें?
So you can make the query to the NPTEL helpline. So whatever. I think there's helpline for students also. So just go to the NPTEL website. So some contact or the help desk email it is given. So you can directly mail them. And I guess the phone number is also given. So you can directly contact them on the phone also. So you have to contact them.
Okay, sir.
Sir, will you take more classes on the previous year questions after the completion of this 12 week?
Sorry, can you repeat?
Will you take more classes after the completion of this 12 week between the
Okay,
time of?
I will take one more class after the week 12, means after the next class. So there will be a session on Thursday, I guess. So yeah, on Thursday. Yes. So you will get an official mail also. And I have already given my class schedule to the NPTEL team. So you will get the official mail, and the session will be on the same time. So basically we will. Yes.
Same time, 7 to 9.
Yeah, it will be at the same time, 7 to 9. So basically we will be revising, and mostly whatever questions, whatever queries you have, we will discuss. So the course content will be done by the next week. Already all we will do is just the one-to-one interaction and the revision of the all over course. So it is a kind of extra class.
Next Thursday, many classes are scheduled. The same time, 7 to 9.
Okay. So because it is happening because the Thursday is the deadline for the extra class, and our regular class is on the Tuesday. So it is Tuesday, Wednesday, and Thursday only. So I have some commitments on the Wednesday. So I have the only choice is the Thursday. So one thing you can do, just you can check the recordings. Otherwise, if you have any queries, specific queries, you can either mail me or just text me or whatever you can do. Just contact me, and if I have the answer, I will just reply back to you.
Okay, sir. Thank you.